In this video, we'll talk about what are the steps we need to take to do an empirical analysis. So before we start, it is really important for you to remember that when we're thinking about a relationship between two variables or measuring the effect of a policy change in economics, both the knowledge of your theory, economic theory, and the empirical analysis would be important. Okay, so I want to emphasize here that just knowing the econometric tools isn't enough, because a lot of the model building is based on the economic theory or the conceptualization that you learn there. So since we know both of these are important, in an empirical analysis, we really want to use data to test some sort of economic theory or quantify or estimate an economic relationship between two or more variables, as well as determine or quantify the effects of some sort of a policy change or even an intervention. Like in the last video, we talked about giving incentives for people to get vaccinated. Now, econometrics is going to allow us to do all of that. We can analyze the data and we can borrow from the statistical knowledge that we have, okay? So to start with an empirical study, it's very important for you to come up with a simple question. So first, it should be a simple question. Maybe you want to figure out or estimate the effect of one variable on another. For example, did giving out the incentive, the burger incentive at Shake Shack, have any effect on vaccination rates? Or something like, does attending lectures in college lead to better grades on average? Right? So these are average effects that we will talk about throughout the course. But you want to come up with a simple question. So if as long as it's simple, you're also going to make sure that it is precise. Okay, so you're going to pose a question. That's step number one. There's another example here which says, if the severity of punishment for certain crimes increases, do crime rates fall on average, right? So you can again think about this econometrically. So that was step number one. Step number two requires you to specify some sort of an economic or conceptual model, which usually is very intuitive, to study the phenomenon you want to study, the relationship between two variables. Okay, so when we think about economic models, whether you're thinking about theoretical models or empirical models, there are certain set of mathematical equations that are part of that model. So in, let's say, your micro courses, you remember that we talk about individual consumption decisions that households make or individuals make, and those are usually guided by some sort of a utility function. So there's a utility maximization problem, and those types of decisions are always subject to some sort of constraint you have in terms of resources. So there's a budget constraint that we think about when we think about individual consumption decisions. And that type of formulation really leads you to come up with some sort of demand equations, which basically says that the quantity demanded for any good or a service depends on its price. It depends on the price of the substitutes or complements. It depends on your income. It depends on your tastes or preferences, and maybe it depends on the expectations that you have of the future. So all of these factors might guide what is the demand for that good or service. Okay, so sometimes you're able to get by with some sort of economic reasoning, which is less formal than mathematical equations, but typically you would have mathematical equations involved. So let's think about this really interesting example, which has been talked about. It's almost in every econometric book that it would be mentioned. So this is really when you think about how do you model criminal behavior? How do we know what are some of the factors that might guide how much time an individual spends on some sort of illegal activity? So this was some influential work that Gary Becker, who was a Nobel Prize winner, wrote back in 1968. And he had this model of criminal behavior that he published. So he thought about a utility maximizing framework, but let's think about it conceptually here. So let's think about some sort of a supply function for time, right? For time, and when we're thinking about time, we're thinking about really an individual. This individual is making a decision on how much time they want to spend doing illegal activities, okay, versus not. So you want to think about what are the factors that would affect criminal behavior. So again, when you think about any sort of relationship, it's always good to conceptualize using something like this. What we did with the demand equations in the previous slide, you can do that here. So you can say, well, criminal behavior Y is dependent on or maybe correlated with certain factors, right? So you can have certain factors. And this is a good time to pause and write those factors down before listening to the next part. So the idea here is that factors might be known. So all of what you guys got in X1 through X, maybe you had 10 factors that you came up with. But basically the idea is that even though you know the factors, this functional form where we say y is f of x, the functional form might be unknown to us, right? This concept is very similar to like an individual not knowing what their utility function is. Is it, Cobb-Douglas, or is it a logarithmic function, etc.? So that's the idea here. But in this course, our focus is on econometric models. So we must go from that conceptualization to turning that into an econometric model, okay? But first, we should really think about a few things. Maybe when you wrote down those factors, you came up with a variable which is saying that the time that you spend on an illegal activity probably depends on the probability of being caught, right? So if the probability of being caught is really high, then you might not spend that much time on an illegal activity. Or maybe that really depends on the rewards of or the benefits of getting or participating in illegal activities. Similarly, like I said before, we don't really know the functional relationship between economic variables. So how do we think about that? And also, how do we control for unobserved factors that make the relationship between variables inaccurate or inexact? Okay, so let's turn the economic model that you all might have written down into an econometric model. So let's think about some of the factors that might guide how much time a person spends on illegal activity. So on the left-hand side is our dependent variable crime, and this is measured as maybe hours spent on illegal or criminal activities. We have wages, this could be measured. It's always, there's some unit to it. So this could be the wage rate per hour that you get for spending time on criminal activities. This could depend on what sort of other income you might have. This could be other income from some sort of assets or other employment, maybe some sort of legal employment that there is. And next we have here, maybe this is dependent on the time you spend on illegal activities, dependent on the frequency of arrests. So maybe this is capturing that probability of getting caught that we were talking about. And then maybe the frequency of getting convicted of a crime, and maybe the punishment. What is the average sentence for that crime? And maybe this depends on some other type of demographic characteristics like age, gender, and things like that. So there's lots of things that could be part of this unobservable, which is you. So once we come up with the economic model, we have turned this into an econometric model. We have actually written out a multiple regression model right here, in which the dependent variable is a function of all of these variables of interest. We can think about another example, which is capturing the effects of job training on worker productivity. So you might be interested in figuring out if people who get a new job, for example, or people who are already working, if they go through some sort of job training, do they become more productive over time or not? Okay, so you can always think about some sort of an experiment. You can have some people that go through the training and some people that don't, and maybe look at their productivity over time. Or and as well as capture other factors that might affect productivity. So one idea here is that when we think about productivity, it's hard to measure. One way economists try to measure this is through observing, let's say, hourly wages. If we really think that, if we really believe that if you're more productive, you end up earning more, then somehow your wages will reflect what your productivity is. So more productive worker will earn more. That's the idea. So if your productivity is more, then your wages, you're paid more. Hopefully that is the case, right? So if we're working with that intuitive approach, then we can sort of come up with this conceptualization that maybe wages are a function of education, experience, and job training. So education could be some sort of a measure for schooling. The number of years that you went to school could be one. Experience could be another one, which is basically the number of years of workforce experience that you have. And training could just be sort of a dichotomous variable, which is, it takes the value of 1 if you went for training and 0 if you did not. Okay. So here again, remember we started with this question, with the simple question where we said we want to evaluate or examine the effect of job training on worker productivity. So what we had done was, in step 1, we carefully posed a question, which is precise and very simple. Second, we came up with some sort of an economic or conceptual model, which is here. And the third step now requires us to turn that economic model into an econometric model. So let's go ahead and do that. Now the econometric model, which is usually written in the form of an equation, sort of a multiple regression model, which basically says that wage is the dependent variable, and the factors that might influence wage, which is giving us a signal for productivity, might be education, experience, and training. Okay, And then there's obviously things that we don't observe that are in U. So the parameters here, beta naught, beta 1, beta 2, and beta 3 are the betas, right? We call them the betas. These are the parameters of the model. And these are what we're hoping to estimate. So hopefully beta 1, when we estimate the model, beta 1 is going to tell us the effect that education has on wages, right? Is that significant? How big is it? And we can test those sorts of hypotheses. And we really want to get to that stage. So once we formulated the econometric model, we want to get to the data. So hopefully we have data on all of these variables that we came up with. So if we are able to collect data on wages, education, experience, and training from a large group of working people, we might be able to answer this question. And remember that in statistics, you always think about a population. So hopefully, there's a large population, and what we want to do is we want to pull some people from here randomly, and the pink ones are, let's say, the ones we pull into our sample, which is smaller than our population, and we hope to estimate that relationship. The idea here is that we may not always be able to observe everybody in our population, even though we want to. We may not have information on everybody because this data that we are trying to gather could be through surveys, or maybe a combination of surveys and maybe tax returns and things like that. And usually surveys can be very expensive if we had to do it for all the 330 million people in the United States or for some other country. But what we can do is come up with some sort of a nationally representative sample that is going to tell us about what is going on in the population. So that's really the idea. When we collect data, we want to do that. So ironically, in statistics and also in econometrics or other types of applications of statistics, we focus a lot on that last term. A lot of the models that we come up with are trying to eliminate the effect of this unobservable, or we're trying to reduce this noise or this disturbance as much as possible. Okay, so this is called the error term or the disturbance, and ironically, this happens to be the most, or at least very important in econometrics. So the idea here is that even though we've accounted for education, experience, and training that we think can affect wages, we might think that there are some other innate capabilities that an individual might have that affect their productivity. So maybe there is some sort of intelligence. We don't know whether this exists or not, whether they just happen to be motivated, or there are some other variables about their background that can affect productivity and therefore wages. So this error term becomes very important. The error term is also important because it can also capture measurement problems in one or more variables. And we'll talk about that in later chapters. Sometimes the measurement errors appear in our independent variables, which are these variables, and sometimes those errors appear in our dependent variable. Okay, so we'll talk about when do we encounter those problems and how do we fix those. But remember that even though we try very hard and we have a lot of complicated models to eliminate the effect of that disturbance or the error term, we can never eliminate that disturbance or error term entirely. So just to recap, remember that we came up with this econometric model after we carefully posed a question and formulated an economic or conceptual model. We can always test different types of hypotheses once we've written out that model. So maybe we want to test the hypothesis that job training has absolutely no effect on wages. So if we are trying to test that hypothesis, then we are basically saying that beta 3, this guy right here, is equal to 0. That would mean that basically training has no effect on productivity, which is being captured by wages. Maybe we want to test another hypothesis, which is to say that maybe having 1 year of experience is worth the same as having 1 year of education. So we're basically saying the effect that education and experience has on wages is equal. So that is to test the hypothesis that beta 1 is equal to beta 2. So we can test different types of hypotheses when we have carefully formulated our question, specified the economic or conceptual model, and then we have turned our economic model to an econometric model, and then we've collected some data on the variables. And then we can finally test these interesting hypotheses and construct confidence intervals to have some sort of statistical inference.